talk about today. So coming back to this Avenging Polanyi's revenge, I'm assuming that you all heard of Polanyi's paradox. Some of you may have heard of it as a Moravec's paradox. Essentially, Polanyi was worried about this fact that mostly science was just looking at explicit knowledge tasks rather than tacit knowledge tasks, the ones that we do, but we don't know how we do it. As against explicit knowledge, where we not only do it, we have an actual procedure for doing this. And so he was kind of, complaining about this, and that he actually wrote this book called The Tacit Dimension, etc., etc. And so the interesting thing is, more recently, starting around 2013 onwards, Polanyi's paradox has become more of a Polanyi's revenge, because essentially we have started sort of taking explicit knowledge as a bad thing, so because it's considered, if you're taking explicit knowledge, then somehow you're cheating. So this is Jeff Hinton giving a talk in Phoenix about his ACM Turing Award, and obviously being a very cutting kind of a guy. So he just said, intelligent design is the one which involves taking knowledge, and learning is the only other way. So you have to learn everything from scratch rather than ever take any advice or take any knowledge from anywhere else. So this sort of became a Polanyi's revenge. So I actually wrote a viewpoint about it in CSM that you could look up if you haven't looked up before. That in a sense, we have gone from forcefully focusing on explicit knowledge tasks to only focusing on tacit knowledge tasks. And if there is actually explicit knowledge available, we take pictures of them. In fact, there have been papers written in GPI, etc., where they have taken pictures of SAT formulas, because why convexes actually understand images apparently. And so you convert all the explicit knowledge into some size format and try to release them. So basically solve everything as if they are tacit knowledge tasks. And that's obviously like an unnecessary swing away from the middle. So in that viewpoint, I was joking around that, the blowhard serenity player should be human grant me the serenity to accept the things I cannot learn, and the data to learn the things I can, and wisdom to know the difference. That's before. As of last couple of years, maybe last year or so, LLMs are interestingly, ironically, avenging the Polanyi's revenge, in the sense that if you are keeping track of it, or I at least put a different spin on what you're seeing about LLMs, everybody has suddenly found that if you ask the LLM, then you get the approximate knowledge. And most of the time they confuse the approximate knowledge with the real thing, and then they start basically making all sorts of errors that only people who have skipped intro to AI to take too many deep learning courses would make. Okay, so LLMs are indeed, ironically, avenging Polanyi's revenge. And so what actually is happening is the old knowledge engineering approach would be, talk to the expert, get the domain expertise, convert into some rules, etc., etc. And then you do inference on them, right? This is your old knowledge engineering approach, the stuff that we are supposed to snicker at. That's LLM, essentially. So the LLMs have kind of automated, getting all this knowledge in some approximate form. And then the question then will be how to reason with it effectively, knowing that that knowledge is only approximate. That's actually not correct. So a way of thinking about this is that if you give what you know about a toy world to the computer and have it solve new instances, that is kind of go-fi cheating. That's not supposed to be allowed. If on the other hand, you capture all that humanity knows about anything, at least linguistically, and feed it out to the computer, then ask it to do toy world instances, at least the knowledge for the toy world instances. That's modern AI, and we are doing it. Okay, there's nothing wrong with it, actually. In fact, since OpenAI spent all its money, we have this doddering old uncle who can answer any question about any possible domain, and they will give some answer, some approximate knowledge, and there are no guarantees. And so can you use that? Okay, that basically becomes the most interesting direction right now for AI. And if you have this as a backup and look at many of the papers, some of which I will mention, not ours, you will realize that that's basically what people are doing, and that is what keeping them in mind. Okay, so what are LLMs? I'm not going to teach you about LLMs, and this is AI too. I hope you better know what's going on. But anyway, so I think of them as models and steroids. And essentially that you want to be surprised, not at the fact that they have 176 billion parameters, that they only have 176 billion parameters, given that if you have a 50,000 vocabulary and a 3,000 word context, you essentially need 50,000 power 3,000 conditional lookup table. And you are taking that, and you give this to, Google, it says it's infinity is the number, 50,000 per 3,000. Compared to that, 176 billion is extremely small, okay? So what you're doing is you are essentially kind of approximating that count table, this huge count table in this, transformer network. So that's what we've been doing. And we all know that LLMs can do everything. As a prompt to be completed, they seem to be doing all sorts of stuff. Down on that side, I think you have people who have realized that, if anything can do pink unicorn, then AGI has come, essentially, right? Okay, that's all fine. But then the thing that I'm most interested in is that there are some wild claims about their reasoning ability. So they can, write poems, they can, give explanations, blah, blah, blah. So the question is, can they also do reasoning? Reasoning of, so in most of AI, if you are taking to AI, there's learning and reasoning, and you need to understand the difference, otherwise you will be paying for your sins. And a lot of people, as I said, who have ignored intro to AI are paying for their sins, and it's becoming hilarious watching them make those mistakes. So the question, of course, is, can they do reasoning? Are they doing reasoning? And that's the thing that I want to answer with respect to planning, which is a particular form of reasoning. I'm not talking about all reasoning, but planning. I know that, guys, people here, I think, including Nuha and co-authors, have been looking at other reasoning tasks, like, for example, even multiplication. So the question is, are they actually able to, can they do reasoning? And can we tell, just because they gave the right answer sometimes, does that mean they're actually doing reasoning? And one thing I want to mention, since Ashish is here, and I know that it's becoming increasingly even hard to see people who understand what satisfiability problem is, because they're reinventing the wheel. So suppose you're getting LLMs or some machine learning system to look at a SAT instance and predict whether it's satisfiable or not, to basically reason whether it's satisfiable or not. It turns out that there is this guy called Davis and Putnam who have come up with this Davis-Putnam procedure that gives you directly whether or not it's satisfiable. That's a systematic 100% guaranteed answer. But if on the other hand, you're actually training a system, you're more likely than not to find that the system might actually look at this phase transition region, for example, and then be able to say that whenever the number of classes by number of variables is way more than 4.3, it won't be solvable. Less than 4.3, it will be solvable, and it could be predicting that. And if you're just going by the answer, you will never be able to differentiate between something that's actually using the Putnam procedure and something that's predicted. But the fact is that any correct reasoner should always be correct. That is something that we have taken. It's not that once in a while I'm correct when you happen to know the answer. And in fact, this is very important because many a time you use reasoning because you don't know the answer. So one recurring theme is I am scratching my head when people ask LLMs questions for which they know the answer and then see, yeah, they are right. It's the same for search too. If you don't know the answer for the search, asking LLMs is a dumb idea because you don't know what is given is right or wrong. There is no guarantees. And so that ends up being very important. So I'm going to push that LLMs are actually not reasoners, and in fact, they can't do planning most of the time. And I do find that you will ask, why is it that Nurix is publishing all these papers, about LLMs are zero-shot reasoners, LLMs are zero-shot planners? My sense is that they're being very unfair. They allow these papers, but they don't actually allow astrologers or zero-shot predictors. I know a lot of astrologers who predict very well, especially if you do chain of thought reasoning, where you pour out your heart and then let them go in the right direction, which again, by the way, is another thing that LLMs, people's interactions with LLMs is, especially whenever this chain of sort of reasoning is involved, you have significant clever hands effect, where you will wind up actually giving the answer away in some subtle way, and then LLM basically will agree with you more or less. So keep that in mind. My main point it is actually, before I actually show you that we can't do planning, is that it's our poor intuitions about approximate omniscience that make it very hard for us to tell whether LLMs are reasoning or retrieving. We all think that we understand, that there's a difference between retrieval and reasoning. We also think that, the particular problem I have, the answer is not present. It's not anywhere on the web. I realize that LLMs are not doing indexing and retrieval. They're doing n-gram completions. But you do know that if they have seen the same sort of distribution and the problems, then they're more likely to be able to be correct, more likely to be able to do retrieval. I think people have very poor intuitions about what is actually on the internet. I know that some of you are young, like you spend a lot of time looking at the web, but I guarantee that you don't really know even a fraction of all the stuff that's on the internet. Like, for example, the first time, remember Bard could explain a joke and people were all surprised. Oh my God, that's like AGI, right? There are enough sites which explain jokes. There are humor challenged among us who don't know when to laugh. And so there are sites that explain a joke. There's sites that explain endings of movies. There are sites that explain lyrics of songs. We had put lots and lots of stuff on the internet, and we have no idea how much we are training these LLMs on. It's amazing that we can do this. But the point is that we don't really have a very good intuition. Because we don't, we wind up being completely surprised. And one of the most important things that I want you to keep in mind is, in general, memory reduces the need to reason from first principles. And those of you in logic realize that if you have base facts, and then you're asking the system whether or not a particular theorem follows, and it actually tells you correctly, then you'll be impressed, okay? That it must have done actual reasoning. But what if the system has been trained not only with the base facts, but pretty much a huge subset of the deductive closure of these base facts? That's actually what happens for LLMs and web. So you're kind of surprised. You're thinking that it's actually, doing reasoning, but no, the deductive closure has also been indexed, not indexed per se, but it's been part of the training data. And that's surprising to you. Again, as I say, if you ask me a tough question and I answer it, right? And then you say, how did you reason? I said, no, while coming in, somebody told me that you'll ask me this question, and they told me the answer. You would lose all your interest in my reasoning abilities. If you're not still impressed that I answered the question you asked me, then you should be impressed with the LLMs too, to some extent, because they've seen the answers. And, this is the interview questions, for example, people prepared for interviews. So, remember this old, again, Microsoft on the street has popularized this wire manhole covers round. The very first poor sucker who had to answer that question had to reason from first principles. After that, all you know whether or not, when you ask this question and people answer, is has the sucker actually prepared for interviews by looking at the entire, question banks. It's the same thing for standardized tests. The reason teams can do well on standardized tests is because they're converting reasoning into approximate retrieval. The thing about standardized tests is standardized tests have standardized question banks, and we have to keep that in mind. Okay, so basically, it becomes very interesting to think that there are emergent abilities, but I think that it's just a euphemism when what LLM is doing is approximate retrieval, and that doesn't sound sexy enough, so you say it's emergent abilities. So we have basically spent time trying to establish this in the context of planning, which is what I'll be telling you about. But first, to show that they can't do planning for nuts, but there's no way, and it's essentially we'll give them all sorts of help, but still they won't be able to complete the correct plans. But at the same time, I also show you that the fact that they can come up with an approximately correct plan, maybe, can be very helpful to somebody in the loop who actually has the theory of how to verify the correct plan. You understand what I'm saying? So you guys have this, right? So in mathematics, for example, there are people like Riemann who can come up with conjectures that just maybe more likely to be true. And there are people like Gregory Perelman who can spend his lifetime taking somebody's conjecture and then actually prove it from first principles. And both are important. And without that proof, it's just a conjecture. And so, I think of this LLMs as great idea generators, can be useful in all sorts of things. The verifier is you, if you happen to know the answer, or some sound reasoner. Okay, so LLM, in terms of planning, the kind of roles for LLMs that I look at is essentially, this is sort of, the summary of the stuff that I'll be telling you about, that LLMs generate, you can use LLMs to generate plans autonomously. Units is publishing these papers left and right. Those are all basically bad. You can quote me on this because I'm writing papers showing that. That basically, by themselves, they cannot actually give any guarantees about the plan being correct. Okay. LLMs to generate plans with the help of external planners verified, that's a great idea. As I said, they're idea generators, you should be able to use them. Even more important, LLMs to extract planning knowledge. That's the whole knowledge engineering aspect. So it turns out that most model-based planners need models of the planning world. And in the old days, people would say some humans are writing these PDDL models or these adaptive task network models or something else. You can actually, I'll show you papers of that we're doing, where we tease out this knowledge from the LLM, correct it with experts in the room, and then throw it to the model-based business. And then finally, the least interesting part, how it can be done, is LLMs as translators. LLMs are amazing translators. So if you think that people don't know how to put parentheses to give PDDL goals, but they want to write it in pitch in English, you can always convert it to that stuff. And we have done this all before. So those are the things, and the green ones are the ones that are definitely possible. So can LLMs plan? I always they can't, but so a while back, I wasted time trying to show Sussman anomaly, which is this particular problem. Can you solve it? And then it actually comes up with a plan, and then it's wrong, then it is wrong, and then some other plan, and it's wrong. And so after some amount of time wasting this, then I basically realized that LLMs don't solve planning problems. They are essentially going to let you solve it and then take it. Because most of the time you are looking for it and you are only too happy to give credit. I don't know why we do this, because we're just so damn impressed with LLMs in general for good reasons that you somehow want to give them the ability to do listening too. So essentially they are just lazy ones who would keep on making you correct their plans. And if you're anyway correcting and you know when to stop, why are you using LLMs? I will understand if you have a little kid and you're trying to teach them Sussman anomaly, which is an amazing life skill, I guarantee. And then you're trying to get them to solve the planning problem. You tell them how to get to the correct answer. I understand. But if you're doing this for LLMs, you're wasting your time, in essence, right? So this is what we said like 1.5 years back, that large language models still can't plan. And this was actually the New York's foundation models, which by the way is another name that I hear, but it was in that particular workshop, foundation model-based decision making or something. And one of the funny things is, if you say that LLMs can do something, people say, yeah, I guess so. If you say they can't do something, that's news. It will actually deserve a lot of scrutiny. I think I was actually, in fact, hearing Agents talk last week, and the number of people who are asking, are you sure, did you give the LLM the right amount of credit for only being wrong most of the time in multiplication, right? This is the kind of thing that we are into. So anyway, so it was actually, it got a lot of some traction. People were surprised that actually they can't do, and then people are interested in, and some, of course, obviously, I'm sure Dan would have agreed, but even Jan, I read that obviously that they can't do that. Okay, will GPT-4's AGI sparks help? Right? I mean, that was GPT 3.5. That's actually GPT 3. And then GPT 3.5 and GPT-4 came to the AGI sparks help. This time we actually wrote a paper giving like a very standard framework for looking at all different ways of calling, with multi-shot, with single shot, with different kinds of prompting techniques and so on and so forth. And I'll give you the link to the paper later, but so we did this, and then we gave this to GPT-4 and also installed GPT-3, and GPT-4 can do 34.3%. Correct. I have to tell you that the way what I'm doing in these cases is I'm taking, there is this thing called IPC, International Planning Competition, just like SAT competitions, there are planning competitions where they basically give these specific domains written in PDL, we take these domains, we generate 500 per domain random problems of different lengths, etc. We analyze those lengths and that stuff. And there are planners that will guarantee correct answers for these. And we just essentially are giving this domain description and the plan as the problem as the prompt to LLM, and then letting it say what the plan is. And then instead of saying looks good to me, we give the plan to a verifier. And the verifier says yes or no, because this is the correct plan or non-correct plan. And if you say yes, you'll get, if it's correct, you get 1 point. If you're wrong, you get 0 point. That's what the thing is.
Yes, question. On your last slide, you had the 34.1. What's human performance?
Yeah, I'll get to that too. Okay, because this is all very interesting thing. On one hand, we are very impressed that LLMs are way better than us. But on the other hand, if we are actually saying LLMs can't do something, you say, do you know whether or not normal run-of-the-mill MTurkers can do this stuff or not? Okay, so actually, and I'll give you in a minute, but the MTurkers do 70%. But the more interesting part is not even 34.3%, but what we did is, so this is like, you lost it. So we got a bunch of Turkers, we paid good money to them to solve the same exact problems, and they have about 78%. These are unwashed Turkers, right? They can still do, and basically they don't really feel like answering the questions, and yet they were getting about 78% accuracy on the plan problems. Okay. Now, here's the interesting thing. 34% looks like a reasonable thing, going from 3%, right? The question is, are LLMs retrieving based on the names, or are they actually doing this? Remember, I told you that if you only go with the answers, you can never be sure. Okay, so I'm showing that you are not actually doing reasoning when you give an answer requires a lot of cleverness required, increasing cleverness, right? Because, and so one thing it turns out it actually works here is late Blowhard actually did this where basically at that time when people were trying to use domain-specific techniques for domain-independent planners, he tried to change the names of the words used in the domains, and he would call it mystery domain. Okay, and so we did this for LLMs now. Okay, so this is the mystery blocks world domain. Instead of saying picking up a block, we say attack an object. Unstack a block from another block, it's feast object from another object. These are English words. Okay, you know that reasoning, like Shakespeare said, arose by any other names, not just as sweet. A reasoning problem with any global replacement of words is the same exact reasoning problem, right?
Is that true for people too, though?
Yeah, we'll tell you that. Okay, so the more important question for me is, I am actually asking whether or not LLMs can do reasoning, right? And if they can do that, so what happens is the moment you actually do this, GPT-4 falls down very drastically, close to 0%, 0.4% as well. Okay, and so plan generation mystery blocks words setup should give you an idea that they obviously are not doing. This is the same kind of thing like we fight the heck out of LLMs on 3-digit multiplications using AI tools considerable resources, and they fall flat at the 4-digit multiplication. And this is not how we want listening to actually proceed. Right? So the state tracking and fine-tuning, they help. I think, first of all, I think fine-tuning is a somewhat silly idea because, in essence, you are helping LLM convert a reasoning task into an approximate retrieval task desperately by giving tons and tons of examples. I don't quite know who's going to impress, but we actually tried that. It turns out that state tracking, that means actually kind of giving them prompt to keep track of the states, intermediate states, and checking that, in fact, the final goal is present in the state. The way we would tell people, don't do it, doesn't work for LLMs. It doesn't actually change anything. I have slides to show that. That's basically the step-by-step plan generation, and that's how the state tracking prompt shows, and there's a paper with appendix, everything that sort of tells the LLM, this is how states are computed, and this, you should make sure that you basically, when you're putting an action, it's actually conditions are present in the state. It doesn't help. Okay, and then similarly, fine-tuning doesn't really seem to help that much. Again, in the case of fine-tuning, you have to understand, you have to ask yourself, is it really worth it? If I'm just giving tons and tons and tons of 3-by-3-digit multiplications, and it does slightly better on 3-by-3-digit multiplications, but still fails pretty badly on 4-by-4. What the heck is the point, right? So, but anyway, it turns out that it's not like it's doing huge generalization. So it actually cannot do much with the fine-tuning too. So that's the paper that's available on the web, and with these are the students, Karthik and Matthew and Lynn and Sharath, who's a former student, who's a faculty member now in Colorado State. This, is basically gives all the information about that particular thing. We actually presented it in the ICML workshop, one of the workshops, and I'm sure it will show up somewhere in the conference too. Okay, looks like we showed that LLMs can learn, hopefully. Right? I mean, you guys are. I'm sort of teaching to have choir here because you guys already, probably agree that they don't do reasoning. So, and some of people agree with that. Essentially, like, Jan, he keeps throwing this as his part of his talk, showing that LLMs can't do reasoning. That what comes to plans. On the other hand, the literature seems rife with claims about LLM planning abilities, new system publishing these papers. Okay, so the question then is why this divide? Yeah.
Did you create challenge problems and popularize them?
So basically, the original paper, this paper is a benchmark, and it was made public, and people have actually used it, and mostly they agree that it is right.
But the Europe's papers are using.
Europe's papers, and that's part of what I'm trying to explain. Because, this is part of it is people don't pay attention to intro AI concepts, and it's just because they did not get exposed to it, and so you will badly deconstruct them. And that's what is happening. That's what I'm trying to explain. So partly it's kind of teaching thing. So why this divide? I don't really believe that people are deliberately misleading anybody. They are just subconsciously leading themselves at best. Okay. And so what is planning and what are LLMs actually good at? This is a useful slide to keep in mind. So planning, as used in the common parlance, involves, if you want to do any planning, you need to have planning knowledge. What are the recipes, what are the actions, what are the macro operators, what are the hierarchical task network schemas, etc. And then plan generation verification techniques, which involves combining these actions, sequencing them, making sure that there are no interactions. If you have subplans, sequencing, merging them, making sure there are no interactions. If in fact, all planning involved is just essentially downloading recipes from the web, then all of us would be able to do all sorts of planning. It's just that when you combine these recipes, there will be interactions, maybe resource contentions, etc. You need to correct it. That's where the reasoning part comes. This is planning, and this is knowledge, and this is reasoning. Right? LLMs can accept any planning problem, even if it's not expressed in any particular PDF standard or something, but they can give you some plan, but there's no guarantee at all about correctness. That's a useful thing, because compared to that, PDL planners might say, if it's not in my language, so I won't even touch it. On the other hand, PDL planners or any formal planners will touch it, they will give you full guarantee. This is the correct answer. If I say it's correct, it's correct. You can take it to the bank. Contrasting that to what I said, AI planning do, AI planning essentially gives the guarantees. LLMs generate ideas for pretty much any possible kind of planning. And the interesting thing is, for people like Dan, this goes back to Noah, the El Sacerdote's work on planning, where he would essentially have a plan and multiple critiques will essentially try to see if there are specific problems they can identify in the plan and correct. Okay, and so after they correct, then the plan is slightly more correct. If you have complete model, then you will give guarantees. Otherwise, you just make it at least more correct. And that's a very useful way to look at it. So if I'm saying this, so in particular, if I'm saying this, they ignore, LLMs basically ignore interactions. They don't know how to deal with the reasoning part. They're essentially doing approximate retrieval. How do I know that this is actually true? So here is a way we take the fact that if interactions don't matter, can LLMs, then retrieval becomes reasoning. Essentially, it's sort of like if you store the entire reductive closure, then reasoning is retrieval. Okay, so when would interactions don't matter, you can take a planning domain, remove interactions by removing their delete effects. That means they can't get into each other's ways. Then remove the preconditions. That means all actions can be done in every place. This is like very relaxed domain. And the question is, in those relaxed domains, you can actually show that GPT-4's performance is much better. You understand what I'm saying? It's still not fully correct because the red part still shows that it still makes mistakes. Because, we all know that GPT-4 can't count, right? So if you have like 5 goals, they should at least be 5 actions supporting all those goals and making sure that all goals are actually supported. We can't do that. So even without preconditions, even without delete interactions, it still does badly. But the fact that it does much better as you relax the domain sort of gives you reason to believe that it's actually doing approximate retrieval. Okay, so then how come LLMs are trumpeted as doing planning? So most cases where they're doing planning, they do things like wedding planning, recipe planning. I don't know how many of you are considering getting married with an LLM plan. I would advise against it. You know what I'm saying? It's nonsensical because it's like useful, right? The following big steps are there. But your wedding to actually happen without interactions, without file engines pulling up, without licenses being revoked, you should have taken care of a whole bunch of interactions beforehand. You see what I'm saying? So the same thing with essentially travel planning. And if you don't do that, essentially, these plans will become, they're just canned plans that are not at all customized to the constraints of your particular situation. And so the plans are not guaranteed to work. And of course, you say, I'm happy enough to have a plan and I will improve it. Great. That's a very useful way of using LLMs. Right? If you happen to know how to deal with interactive language. But don't say that it's solving the entire planning problem. It's not. Okay. So all the interaction resolution part, and I'll show you some examples in a minute of all the published papers, which say that they're doing planning, they essentially are just doing recipes. And the interaction resolution part is either pushed under the rug or they're dependent on the people and the quote unquote chain of thought. So if you're doing that, then you're at least doing a huge part of the planning problem, and not that the machine is not doing it. And that's worthwhile is remembering. So in particular, if you are correcting a plan that LLM gave, and you are a bozo in coming up with wedding plans, then your wedding will still not happen because you haven't looked at all possible interactions. So whether or not the corrections you did are actually going to work depends on whether you know the theory of the domain well enough. Okay. In the cases where you know the theory of the domain, LLMs can come up with plans faster for you, ideas for plans faster, and you can correct it. And that's a very useful thing. That's what I said was the knowledge engineering part. So here are some of the things that people talk about when they talk in terms of LLMs and planning in the Unix papers. React, inner monologue, and tree of thoughts thing. Which they're basically, if you look at it, behind all the formulas and behind all the excessive commas, etc., they are retrieving land fragments, which are not guaranteed to be correct. And then the so-called COD is your attempt to fix the plan. And if you are happy that it's fixed, then it's fixed. Otherwise, no guarantees. Okay? And that's basically, and so believe me, this was a New York Times article, I'm sure some of you have read, that says, just like wedding plans, there are people writing travel plan books because, and the Rick Steves, the poor guy who actually started writing that, he said, I'm not worried about LLMs at all because, if you're a sucker, buy this because you save $3, but it's a useless plan. Because you haven't actually, you just basically looked at this, looks like a travel plan. It doesn't actually work. It hasn't taken into account the fact that if you go to Uffizi Museum, you also have to have like called beforehand this obscure number and get a license to get in. Otherwise, you just go and see the outside lab surroundings. So the interactions have to be handled. Okay. So what if this is about LLMs can't do planning and why people are getting confused about it? The next part I want to talk about the positive uses of LLMs in planning. What if we allowed LLMs to interact with external planners and verifiers? It turns out that that's actually a great way to use because they're just basically generating ideas, and if there's a tester who has good model, that can use it. And so we have considered, a workflow in the same paper that I showed. We considered a workflow where the LLM's plan is given to Dan will know LPG, which is a local search planner, and basically it has a complete plan. LPG happens to be a complete, local search planner, which takes a complete plan, analyzes the flaws in it, causal links are not being supported, etc., and fixes it. except it starts from its own original plan. Here I'm letting LLM give the plan, and then it corrects it. And when it's correcting it, it has the full domain model. It actually, what it's doing is improving its search. And we show that with this, LPG actually does faster search. So the idea that LLM comes is not guaranteed, but it's not completely nonsensical either. But if you're looking for a correct plan, LPG is helping. This is exactly what I would do. If I'm stuck and one of you are passing by, I say, hey, do you have an idea? And there's no skill in the game. You say, yeah, here's an idea. Take it, I'll leave it. And then if that idea is good, I get to use it in my context and I'm happy. You don't owe anything for your idea being correct. Okay. The other much more useful way to use it actually, so it turns out that giving it LPG, LLM plan to LPG, is actually a new way of doing case-based planning for those of the people who know, which is there's this old work like Chef, etc., which will have a whole bunch of plans that it will put in the memory and it will retrieve. Here you put the entire word, not in the memory, but in a non-veridical memory, and you are just making an appropriate, reasonable case by asking LLM to suggest a plan, and then you correct it. And that's actually a very useful way of thinking about it. So you can think of LLM case-based or LLM hierarchical task network planning, where you use LLM. I'll tell you in a minute. You can use LLMs to come up with the planning knowledge, including PDL and HTML plans. So the other part is actually back prompting, where we will allow the external verifier to not just say, yes, the plan is correct, no, the plan is not correct. But, the plan is not correct, but here is a condition that you're not supporting. Here is an aspect that you're not supporting. And so this can be automatically converted into a prompt, and you send it. So it's a back prompting, think of it as back prompting, and there's no human involved. And with this, actually, we see that within about 15 iterations, LLMs will solve as decided by the outside external. So, for example, you don't know how to answer the question. You give me an answer, I say, no, try again. Give me an answer again, try again. And so after 15 times, I say, yeah, you're right. And within 15 times. Then you still don't know the correct thing about domain, but you basically, because you have given more chances and you are using this back prompt to actually change the conditional distribution, right? Because if you change the prompt, you are essentially looking at a different completion, which, by the way, I hate the word in context learning. There's no learning, right? It's all been computed beforehand. And it's like conditional plan. We're just figuring out which condition happens to be true because we execute the context. So it turns out with back prompting, they actually do significantly better. And again, would I be doing it this way to solve these planning problems if OpenAI didn't waste all its resources to come up with GPT-4? Of course not. But it exists, so I don't mind using it because it finds it being cheap enough. Okay. LLMs assisting human planners is another way. In fact, in the other case, there's actually there's a domain model that's correct, and then the LPG or the verifier valve are working off of it. LLMs can essentially be, you can be using the plan and correcting it. Okay, that's basically a very useful thing. And in fact, as long as you don't delude yourself and thinking that after my conversation, LLM learned something, if you just take it as an idea and improve it, so it takes less time for you to come up with a plan, it's a very reasonable thing. So one problem in general with LLMs assisting human planners is the automation bias. We have actually shown in the results that sometimes people think that because LLM said so must be the plan will be correct, and they'll try to execute it and they'll take all that on their face. This has been happening with Google, it will happen with LLMs too. So, but if LLMs can guess reasonable solutions, can we just call them multiple times until they generate the correct solution? This is the delusion that is happening currently in all of LLMs and reasoning. The problem is two problems. One is they don't know when to stop. Somebody should know when the answer is correct. And if you know the answer, then you have to ask yourself, what exactly are you getting out by asking LLM to do this for you? Sometimes that is useful, sometimes they're not. The other thing is, when you are giving these prompts, in essence, you may well be giving away the answer that LLM then repeats. In fact, there's actually this stuff that I've been assuming for a long time, and I basically, Clever Hands, the very famous European hearts that could do addition and subtraction. And it turns out that what it was guessing, what it was actually looking at is the stress level of the owner. And the owner was, well, his stress level was increasing. This guy, his stress level was increasing as the heart started to, the foot, it's supposed to be stomping its foot to, if you say 4 + 3, it should stomp its foot 7 times. So when it comes up to 6, this guy's stress level is increasing. Like, and that's what the horse was guessing. That's what clever hands is. This is actually a very well-known phenomenon. If you haven't seen it, read up in the Wikipedia. Okay, so much so that my version of LLMs and reasoning is the impressive reasoning abilities of LLMs, prompter knowing the answer. This is okay for essays. If you're trying to write a statement of purpose, like these days now, when I get international students asking, work with me, etc., they're all beautifully written. The form is like amazing, right? But amazing. Okay, and the content, okay, but because the content is the same as before. So the point is, so here, if you are basically, what the essay should say, you put it bullets and you convert it to email form, and then I get the email, I convert it back into bullet form, and we both nicely increase the traffic on the web or nothing else, which is okay. But if anything else, like a categorical, logical problem, etc., if you don't know the answer, when do you know the LLM is right or wrong? Okay, that's very important. So much so that I wrote this amazing paper, at least the abstract of it, Forest of Jumbled Thoughts Prompting, an ultra general way to use LLMs for solving, planning, reasoning, world peace, and climate change tasks. You might think that people will know that this is a made-up thing because I'm saying this, but the level of it must be true. Maybe LLMs can do that too. Has increased so much that I get more requests for the actual paper on this than my real papers. Okay, and so people can't even believe that it can't do it. And so, in fact, I do request you to read this, and if you want a joke, an inside joke. So, for example, it has the following sentence: "We prove by reduction to Rube Goldberg machines that the forest of jumbled thought prompting eventually makes LLM solve any problem for which the prompting graduate students know the answer." It turns out LLMs can do miracles with graduate students in the group. And especially with the university deadline. And so you have to keep that in mind. And so much so that, this was the New York Times quoting me saying that if you don't know the answer to the question already, you should read it to LLMs. Because how do you know that it's correct? At least for the Google, it's correct in the sense you believe NIH. And NIH would not have put this information unless they have vetted it. Otherwise, and of course you can say, maybe we can make LLMs do citations, and then you would be like that liar who made the cases up. And the judge basically threw it out. So that part is the problem. So actually, I like this TikTok. I don't know. I tried to take a screenshot of it. This kid essentially is a great LLM. He's watching a sport, and the father basically, something happens on the TV, saying, and the kid starts saying, "Yay!" and then looks at the father. The father is actually it's the other team that's doing well, so the father is sad. So the kid also does that. That's what chain of thought prompting does. To some extent. So I think this guy is doing extremely good chain of thought prompting and he's getting. This is actually a more nuanced thing I can talk on one-on-one, but we can actually, this mechanized critiquing of LLM plans is possible as long as you know where the knowledge resides. External model-based verifiers doing the critiquing. I told you about the back prompting. You can also consider simulators instead of models. And this RL versus planning difference is really falls down to RL. People think simulators fall from trees. It's people who write the simulators. And so the people who wrote the domain models also wrote the simulators, and it just wound being easier for them. So you can be using the simulator there. And so that would also be, you can use the simulator and do back prompting with that, and that's a very reasonable way. Critiques can be sound but incomplete. This is the NOVA idea that I was mentioning earlier. That would still improve the correctness of the plan a bit more. Feedback from the world is what people say they do, but these are people who don't realize the difference between ergodic and non-ergodic words. Okay, if you're actually doing the plans in your world, not in a simulator, if you die, you die. You actually might do, even on Linux, you can do a nice RM star and see what happens. And then you can't recover from that. So you have to keep that in mind. Plus, world is very laconic. It just gives you, it doesn't tell you, by the way, you are wrong because of the following thing. It's like you have to figure out what went wrong, and it's very different. LLMs verifying their own plans, this is like a new delusion. that LLMs are better at critiquing themselves than generating. It's true for you. We actually do this. Oftentimes we come up with a plan, but then we can spend time in figuring out what part is right, what part is wrong. There is no reason to believe LLMs can do that. In fact, empirical results show that they don't do any better verification than they do generation. However, you can. So here is one piece. This, by the way, is your grand kid, awesome student. We basically work with Taman to show that if you actually start with GPT-2 and you essentially do fine-tuning, but then you have two versions of GPT-2 that are fine-tuned, one to generate, one to just verify. And this becomes a difference between generative versus discriminative classification, and discriminative classifiers are more sample efficient. And so basically you have these two versions, and then you put them in a loop. You can actually show that LLMs improve. LLMs, the version of LLM verifier, learned LLM verifier, can improve the correctness of the learned LLM generator slightly better. But still, these are the results themselves are based on we actually using the full known model to check the correctness. So that's possible. The last thing I want to bring up is LLMs can extracting planning knowledge. As I mentioned, that's actually the most useful thing you can do with LLMs because it's this whole knowledge leading aspect. And so there's a paper that Lynn and Karthika involved where we use LLMs to actually bring out a PDL model, basically prompting them to come up with a PDL model, correct that PDL model both in a semi-automated fashion with some critiques as well as the human experts in the loop, and then show that, oh my God, and then show that in fact that improves the time taken as well as once you correct the model, then you can use that for a model-based planning. This is actually a very reasonable thing. Within planning community, people ignored where the models are coming from. Somebody had to write it. Dan knows the knowledge acquisition part of it we will not go there. We will all be very seriously looking at the interaction resolution people, but that's important where the models are coming from. And LLMs are very good at that. In fact, there's an ICML paper last year. We showed that if we give a deep reinforcement learning system a symbolic model that is incorrect, so basically approximately correct. Okay, then the simulator at the lower level can still be improving its performance quite significantly. This should not be surprising to you because deep reinforcement learning is a slightly silly idea where you basically are doing things at the pixel level or very primitive level. So giving high-level advice of any kind can improve its performance. And so we showed this when we wrote this paper. We gave the model ourselves and we just said this is not guaranteed to be correct. But LLMs are actually only too happy to give models that are not guaranteed to be correct. And this is RL doing it. Basically, to me, my way of looking at it, RL with a simulator is a reason because the simulator is actually doing the backstop. So those of you who have heard of code as hierarchical policies, that's what it's doing, my friends. Okay, essentially they're getting the schemas approximately from the LLM, and then they're making sure that the interaction part is taken care of by the simulator. Now, this actually made lots of RL people very worried, as they should be, because they spurned all the symbolic knowledge before, because they said, we should start from scratch, and the bitter truth is basically coming to bite for which certain, because in fact, this stuff, high-level knowledge is available freely, and it's approximate, and your simulator can do much better. Finally, LLMs can also be used for human preferences as a human preference proxies. And in fact, in the planning, if you want human preferences instead of using Turkers, you can use LLMs. It's basically you're cutting the middle now because, as you all know, already Turkers are actually calling LLMs to check what humans really want and give that back to you, because there have been studies showing that Turkers are not actually doing work for this little money they're getting. Okay, so that's that last paper. So the epilogue, these are the papers that I talked about. And I mentioned that the poor intuitions about approximate retrieval is what actually makes people be confused about what's going on. I think this is a reprise that you should know that planning involves both the knowledge and the resolution part, and you need to have both. And you need to know why people are competing is as planning. Doing planning, what they're doing is I'm getting approximate planning knowledge. I mean, if you look at the 3 by 3 digit multiplication, the answer is in the right form. It does seem to not say, if you say 343 by 947, it is not saying A7, B15, blah, blah, blah. It's only giving numbers. So it's in the right form. It's just not correct. Okay. And the form based, the whole thing about LLMs is, for the longest time, we could get away by conflating form with content because somehow form and content were correlated. With LLMs, that correlation got thrown, blown out of the water. And so we actually have to read the content. This is the reason why English teachers are so worried about, essays being written by LLM, because they are not actually reading the essays. They're looking at, whether or not the essay is in good English. And that part, now everything is in good English. And the last thing, and so this is a summary of what you can do with LLMs that I talked to you about planning. And the green ones are the most interesting. We have done work on LLM translators. For example, you can actually use LLMs as the translators to convert the recipes in text into PDL models. But a version of that is what I was telling you when I did the PDL models from LLMs. The last thing from other people and planning people, I don't know that, that's mostly to Dan, I guess, is that for too long, people tended to assume that there's a race to the bottom of the level of knowledge given to the reasoner, saying, get it from direct, pixel level, failures, etc. But it turns out that LLMs say, I can give you approximate knowledge fast. And so the question is, if you have a doddering old uncle who has a prompt answer for any random question, but no guarantees that the answer is correct. Okay, what would you use that uncle for? And so the idea, in fact, some time back, I used to do this work called model light planning, where looking at planning where the models are not guaranteed to be correct, you have to consider notions of robustness, and think of a model as a sit-in for multiple actual complete models. I believe that might actually become useful. So in summary, those are the summary. I want you to remember that. And that's what you do. Thank you.
Yes, we have 2 minutes for questions. Then we'll be here till 4 p.m.
Yes, go ahead.
I want to make one tie-in from the business of not being able to understand when we're doing retrieval on these problems. I just wanted to make a plug in, a tie-in, that it seems incredibly important for the people who create LLMs to publish the training data that's used. So, of course, AI2 just released the blowhard model. I think you should plug that in your talks.
Yes, except there's a panel in knowledge and logic and reasoning workshop that's available where I took a stance saying should not be required. So if you come into my room and you answer a question, I don't ask, Dan, what are all the courses did you take? What all schools did you go to? How did you get to answer this question? I could get the answer. Why should LLMs be any different? So I'm actually supporting that. I think it's okay if you give the knowledge that you trained on, but there's a whole bunch of stuff on there.
I agree that it would be great if they could explain themselves, and we should be striving to do that.
I'm not talking about explanation.
You just asked, you asked, Dan, why did you, we should do that. But as in the intermediate, I think we should be understanding the training data. I think we're understanding what the LLMs are doing.
The easiest thing is for me to agree with you, but I won't, because I think ultimately any reasonable LLM would have so much data that saying that this is the 600 gigabytes of data I trained myself on, even if actually these people put it out, you will still have quite a hard time making much sense of it. I understand that if there's an actual lawsuit, you might be able to use this. That's what is actually happening with the artists suing the generative art models kind of a thing, saying whether or not the data for their paintings was actually there in the original thing. But eventually we need to, I'm not against it, I'm just saying that eventually what we are is my lifetime of being exposed to data. And you typically don't ask me what all stuff did I read. You still try to understand whether I can reason well, whether or not it's any way to figure out. And as I said, I would say actually we would get LLMs and these AI systems to be able to explain. That's my other part of my work that we should be able to work. We are working on that. This is a band-aid. I think it's a nice thing, but I think
Nice
eventually,
Band-Aid. Good. I'm happy with
yeah,
that.
band-aid is good. Yes, sir.
Will it be magnified if in the future models are trained on data that has been generated by them?
It'll be much worse. Much worse. In fact, I basically, as you know, mostly instead of making slides, I use screenshots of my tweets because that's what I do. I used to actually, tweet everything that I'm thinking of. And one of my tweets was just like there is this Norwegian seed bank where we stored all the seeds in case there is like a nuclear holocaust so that we can still bring back everything. All of you, when you go back, should take a snapshot of the web and store it, because it will be badly damaged with all the LLM junk. And so we can't tell what is actually, even 4chan is better than what LLM is generating because there's no intent. It's just an actual n-gram completion. And so this is going to be a huge issue in terms of, whether or not. And then one related point that I do want to make, it's actually from a slightly different version, is as much as we think that we have everything on the web that we put, the thing that we didn't put is how did we come up with the answers? Typically, there is this idea in case-based reasoning and analogy literature that there is this idea of derivational versus transformational analogy. Transformational analogy just looks at the case and tries to kind of change it. Derivational analogy says, how did you get to that place, the entire search tree, including the failures and including why you didn't take some other choices. And if you store that, the approximate retrieval can be much better. So in fact, the more recent paper by OpenAI is saying we are making LLMs do much better because we are paying people to try to add extra data as to how the a particular solution has been arrived at. That is a very costly way of reinventing the derivational trace. And you know that if we didn't have web and we didn't put all our stuff on the web, if Sam Altman said, hey, this stuff is working, now all you guys have to do is put everything that you know on the web, let's just do it. We won't do it. It just, we put it up and then we used it. And the derivational stuff, we never put it up because web was created for you and me. And you don't really care all the failures that I went through before I came to this place today. You more care about the fact that I showed up. Okay. And so if I didn't put all that stuff, if I do put that stuff, that will improve the approximate review quite significantly, not surprising. But if you didn't, then you have to pay somebody to come up with that. And recreating explanations of correctness after the fact is easier than recreating how the solution has been arrived at. And this was one of my, right after my PhD, I had this paper about this stuff saying, if you lost the derivational information as to what are all the things that you tried that didn't work because of which you tried this, recreating that's extremely good. Yes, Ashish.
So planning is just computationally fundamentally hard problem, right? From complexity perspective, there are easier problems for where verification and even critiquing is just computationally easier than solving the problem. SAT and NP problems being some, but even multiplication and stuff, I can see is the last digit correct. For example. Do you think there's more hope there?
So I think my sense, and I have on the tweet thread called the depth of computational complexity that I'm sure you have noticed. I mean, you didn't see my tweet thread, but AI papers no longer, except maybe your papers and a couple of recent converts, they no longer talk about complexity, right? Essentially, because we don't care, everything has been converted into the offline. And one of the interesting things about LLMs is they are equally bad for, what about the strict planning, which is only piece-based complete, and the additional stuff like conformant planning, etc., XP complete, are semi-decidable. They're just equally bad and equally good, irrespective of what the underlying computational complexity is, because they're not reasoning. They're essentially deconstructing the solution. And so it turns out that if you actually take time, you will find mostly that is not changing their answers as much, That's my sense. And I consider that as actually a positive thing because, as I said in one of my slides, that one of the things that LLMs are good at is they'll never say, we don't know how to solve this problem. They'll always give you a solution, which is actually good from the perspective In fact, again, Dan would know this. There was this old paper called Two Theses of Knowledge Representation, written by Ramesh Patel, John Doyle, who basically said there was a time when knowledge representation people will say, unless what you want to tell me is Hahn clauses or descriptive logic, I won't take it because it's not practical. And these guys said, we shouldn't do that. You should allow users to say what they know, and you do the best you can. LLMs actually do that, right? And so my sense is computational complexity is a thing to keep in mind, but I don't think their performance is really that dependent. Unless there are cases where, for example, you can actually train them. That's what happens in the 3D multiplication maybe, and it can also happen for SAT, like the CSP of a certain length, where you can basically train them on all possible solutions, and then so they will have a slightly better thing. But it's the thing that helps there in the possible solutions is finite, and you're kind of telling me, yes.
The other framing for your talk, and I think, another framing for your talk is the system 1 and system 2 reasoning. And, LLMs seem to be doing system 1, and system 2 is important too.
Yeah, I had slides on that. I just think that I agree with that, but the point is that a little more. I think that's a very reasonable thing. I mean, essentially, and fine-tuning converts system 2 into a system 1 task, essentially, and memoizing fine-tuning converts that. And I know I have talked about that. I agree with that. Essentially, I just didn't say it. That's completely relevant. Yes, sir.
In tasks where we don't have verifiers and only thing we have is trained test sets, how do you distinguish reasoning from approximate retrieval?
That's actually very interesting. My point is that we do have the distinction between reasoning and retrieval in the contextual logic. But then when you wind up not having the knowledge, right, then you should be aware of the fact that I'm dependent on, again, I think this was a beautiful quote by, I think, Gauss or somebody, that I mean proof in the way mathematicians mean, not in the way that most of the time it seems to be working. Which is that later he put it down badly because as a mathematician, I can still live with it, if there is slightly higher statistical guarantee. To some extent, that was not happening. What was happening in the GPT-2 being trained both as a verifier and a generator, there the verifier has become slightly better. But then again, the interesting thing is, even in that case, I know what the correct answer is. And so I can, as an outsider, look at the performance and see whether the performance actually improved. The more interesting question is, if there are problems where there is actually nobody in the world who knows what the correct answer is, then I have no idea. Right? All you can say is, well, essentially, things haven't fallen apart yet. And that's a different way of doing things. But that's very different from, I think I have this saying that the difference between a computer scientist and a hacker, and in the normal classes, is I tell them, the students, that the computer scientist knows what is optimal versus inoptimal solution to the problem, thinks about the complexity of getting it down, and say, to heck with it, it's too costly, I just do the advancement. Hacker doesn't care. Right? And so the question is, if you don't even differentiate between this and retrieval, and you just go by, saying it seems to be working better, then we are not adding anything more to the current direction, which is, look, it seems to be working, right? And except that they're actually talking about reasoning problems for which I know what is right and what is wrong. And I do think that it's like, and then again mentioned, this is like a great rebirth for the whole GoFi, essentially, because you have to combine the reasoning part with the retrieval part, and it's a good thing for AI in general. And for the kids, they should take it to AI, they should take learning, they shouldn't just give up on it because, they can just keep adding layers. That's no longer. Thank you. Thank you for your patience.